Hi there, everybody. We are doing the 2011 BC number 6 FRQ. We've done this before, but I think it's good reviewing. And some of this stuff actually won't be tested, but there is some of these that will be. So I think, again, it's still beneficial to go through these. So let's go ahead and read this. It says we have a function f of x given. We have the graph of the fifth derivative of f. So we want Taylor series for sine x. And I mentioned this to you. You're not required to know that off the top of your head, but I think all of you do. But you might be asked to create it from scratch. So in essence, you're going to need to know it anyways. So let's take a look at this. Let's do part A. So sine x, they want the first four non-zero terms. Oh, they don't even want the general term, which is nice. So we have 0, then we have x minus x cubed over 3 factorial plus minus. That's our sine function. Then they ask for sine of x squared. So again, this is one of the 5 things you can do to Taylor series. If you're given a series, you can do a composition. If you'll notice, they're just saying instead of x, you replace with x squared. And so all you do is replace all the x's in the previous one with x squared. So we get x squared, x to the 6th, x to the 10th, x to the 14th. And we're done. That's part A. So part B, they want the cosine series. And that's going to be 1. I'll just do this one more term. That should be a minus. Then they want to combine. Okay, so we have to combine these two series to get our f of x series. So f of x equals sine x squared plus cos x. So the Taylor series for that, you're going to combine these. So you're going to combine this and that. And how many do they want? The first four terms. So we're going to get a 1 from the cosine. And they both have an x squared. So I'm going to get an x squared from the sine and an x squared from the cosine. And then I have an x to the 4th from the cosine. And that's the first 4 terms. Let's see what it says. Oh, no. This is one term, so I need one more. So after x to the 4th, I have x to the 6th. So from the sine x squared, I get that. And from the cosine of x, I get that. Now, we are not allowed to leave in this form. We need to combine our like terms. So simply we'd get this, 1 minus 1/2. I'm just factoring the x squared out. And then I'm going to factor out the x to the 6th out. I'm left with 1 over 3 factorial, 1 over 6 factorial. I'm just going to leave it like that. That's sufficient. Now, if you want to simplify that, we would get this. Now, I guess I could get a common denominator. So this, to get a 6 factorial, on the bottom I need times, whoa, not that. I would need times 4 times 5 times 6 on top and bottom. And then they'd have a common denominator of 6 factorial. 4 times 5, that's 120. 121 over 6 factorial. That's it. So simplifying this, the top is 120. 3, 4, 5, 6, that gives us 6 factorial. That's what just happened, if you didn't see that. All right, so we're done with part B. Part C. Oh, this is beautiful. So to find the sixth derivative, you wouldn't want to take the derivative of f 6 times. That would be ridiculous. But we know in a Taylor series that, here, let me circle this. How do you get this term, or actually this term, from a Taylor series if you're building it from scratch? So built from scratch, that would be equal to the sixth derivative times x to the 6 over 6 factorial, right? That's how you'd create that. So you would just make these two equal to each other. Show that. Oh, whoa. So you would just say the sixth derivative, x to the 6th over 6 factorial, has to equal negative 121 x to the 6th over 6 factorial, implying that the sixth derivative is negative 121. Bingo, bango, dunno. All right, part D. You have a 4th degree Taylor polynomial, and you want to show the error is less than that. So this is not an alternating series. Therefore, the error is the next maximum of the next term. So I'm going to say this. Let's go back to blue. Not back to, but let's go to blue. The maximum error is the maximum of the next term. So this is a 4th degree, so it's going to be the 5th degree term, or the 5th derivative. Ooh, that should have a parenthesis around there, or else it'd be 6 power, not 6th derivative. The 5th derivative. Whoa, Yoshida. So you want the maximum of that. And I didn't leave myself enough room, but I can squeeze it in here. You want the maximum of the next term. So you want the maximum. I can't even write. The maximum. Oh, I can zoom in. Cool. Of the absolute value of that term. And C is between the center and the point being approximated. We're approximating 1/4. The center's at 0, so it's going to be between 0 and 1/4, our C here. Bammo. And we need the absolute value of x to the 6th. Wait, 5th. 5th. Over 5 factorial. So how do you find the maximum of the 5th derivative from 0 to 1/4? Well, nicely, they gave us the fifth derivative. So 0 to 1/4, there's 1/4. Here's our function. The maximum value is right around there, which is kind of hard to tell. So you wouldn't want to do, this is 20, like 35 or 30, because you're just not sure exactly where that is. A safe number, a really safe number is 40. Clearly, this point is less than 40. So using this less than or equal to, because we picked a number that we knew was bigger than the maximum, we can replace that with 40. X is 1/4. And we wanted to know if that's less than 1/3000. So I'm going to say it's less than 1/3000. And pretty much done at that. You can double check to make sure that's less than 1/3000, but I'm just assuming because I think we did it right. That's it. We're done. I'll see you on the next problem.